Hello, I am Edwin Ritchie. I'm the Extension Soil Specialist for the University of Kentucky. I'm located in the western part of Kentucky at Princeton at the University of Kentucky Research and Education Center. Today we'll be discussing nutrient deficiencies and causes and how to identify these in the field. The things we're going to cover today are being able to identify common nutrient deficiencies for the major row crops, corn, soybean, and wheat. And we're going to be looking at macronutrients, the nitrogen, phosphorus, and potassium. We'll discuss how they move in the plant and how the movement affects where we see these deficiencies in the plant. And then there's some other factors that lead to deficiency symptoms. And then we're going to wrap up with identifying some tools that can help diagnose these underlying factors, whether it's a nutrient deficiency or not, and then compare and contrast a few nutrient deficiencies versus abiotic stresses. Nitrogen. It is needed in the largest amounts of any nutrient and about the same amount as potassium, but far more than phosphorus. Nitrogen is mobile in the plant, means it will move from one part to the other, and it's mobile in the soil. It is used for photosynthesis. It's the building blocks for protein, and it drives yields in non-legumes. You're not going to typically make a 300 bushel corn crop if you don't add nitrogen. So nitrogen is considered a yield driver. You can look to the right. We have a wheat field with varying levels of nitrogen. Goes from dark green and tall to short and almost yellow, real pale. And that's just differences between nitrogen rates in the wheat. For corn, our nitrogen deficiency symptoms will start on the lower leaves and move upward. This is true for any mobile nutrient. It's going to start on the older leaves and then move upward as the deficiency progresses. First, it will start with mild stunting to yellowing and then browning. Nitrogen deficiency will start at the midrib and then outward to the leaf. If you see this is a normal leaf, dark green, no deficiency, no yellowing. A little bit more severe, it's starting to show here at the midrib and working out more so, and then pretty severe nitrogen deficiency. Um, some of the causes, well, the first most obvious is insufficient nitrogen applied. If you don't apply enough, you can see nitrogen deficiency pretty readily in corn. Some other factors could be the environmental conditions. It's either too wet or too dry. If it's too wet, if the ground is saturated with water, the plant cannot take up nutrients. So saturated soils are going to cause that. If it's too dry, the nutrients can't be taken up either. And then some other biotic stresses would be bugs, weeds, diseases, something that stresses that plant and doesn't allow it to adequately take up the nitrogen. And then we have losses. So what we think about our major nitrogen losses are runoff. We apply it on the surface, hard rain, and it runs off with the water. Leaching, that's the downward movement through the soil profile. Typically we'll expect that in a sandy type soil or something that's tile drained. And then denitrification, that is when the soil becomes waterlogged, the nitrogen will be reduced out of the nitrate form to a form unavailable for plant use, and it's not available for the plant, and it's essentially lost. Moving on to soybean, nitrogen is typically not needed to be added for soybean production. They have a symbiotic relationship with rhizobia in the soil, and the roots will get infected with this rhizobia. They will make their own nitrogen and share it with the plant. This Typically, if you have soybeans, like a corn soybean rotation, you do not need to inoculate that soybean. However, if this field hasn't produced soybeans in 3 to 5 years, inoculation should occur. And one thing to check to see if these nodules are doing what they're supposed to do, if you break it open, it should be blood red. If it's red, it is producing nitrogen. Deficiency symptoms, again, it's a mobile nutrient just like corn, so it's going to start on the lower leaves and move upward. We can see here this lower fore picture is darker green than up here. We can start with mild stunting to yellowing to browning and then early senescence, so the leaves mature faster and drop off. Causes for soybean a little bit different than corn, but poor nodulation or lack of inoculation. And then go back to the poor environmental conditions. If it's too wet or too dry, or soybeans, if the pH gets down below, we say 5, 9, 6, actually probably it's going to have to be a little bit lower than that, but low pH can influence the efficiency of the nitrogen fixation. Moving on to wheat. Again, we start with the lower leaves and move upward, mild stunting to yellowing to browning. It will start at the midrib, work outward towards the leaf tip. We can see here this is a well-fertilized wheat plot, whereas over here these aren't as well fertilized, they're more yellow and shorter. So nitrogen, again, yield driver. We're going to repeat a lot of these things, but it always helps to hear it a lot. So what can cause nitrogen deficiency in wheat? Well, not applying enough, the poor environmental conditions, it's too wet, too dry. We can have some winter cold injury, so it's just not able to function quite as well. And then these same biotic stresses, weeds, bugs, diseases, things that actually hurt the overall health of the plant. And then back to the nitrogen losses, runoff, leaching, and denitrification. Older leaves are the lower leaves here. You can see the yellowing, and it kind of progresses up with the plant. Phosphorus, the second macronutrient, it's needed in the smallest amount of any macronutrient, about 1/10 of the amount that nitrogen and potassium are needed, but it's very important. It is mobile in the plant and relatively immobile in the soil. So like nitrogen, it'll move from the oldest leaves to the youngest leaves when that plant needs that phosphorus, but when you apply it to the soil, it's not going to move more than a centimeter or so from where it was applied if it's not incorporated. If you surface apply it, or if you incorporate it, it's not going to move much from where it finally rests. It's used for DNA and RNA production. If you think about DNA, that's the genetic material that is found in the seed. So kind of influences seed production, and it's considered the energy element. We can see phosphorus deficiency here, not a super strong case, but we can see the purpling on these lower leaves. The deficiency symptoms, it starts on the lower leaves and moves upwards. We can see quite a bit here. The purpling, not quite as much at the top. It's working its way up. Stunting, we can see that here in the mid part of this picture. Pretty severe phosphorus deficiency. It can delay maturity and, of course, hurt yield, just like any severe deficiency. The same causes that we're kind of running in with the nitrogen, don't apply enough, insufficient P applied, poor environmental conditions, too wet, too dry. Well, coldness influences phosphorus quite a bit. A lot of times the early planted corn is not going to be able to utilize that nitrogen or phosphorus as well. It won't take it up as well, and we'll see this characteristic purpling of the corn leaves. Limited root systems. If that root system is not sufficient, it's not reaching out. Remember, phosphorus doesn't move that much in the soil. So if you have a small root system, limited amount of phosphorus near that root, that can influence. When our pHs are too low or too high, so if we have a pH below 5, 5.2, we can have the phosphorus being associated with aluminum or iron, tying it up, making it unavailable to the plant. Or when it gets above 7.75, it will be bound to calcium. So that ideal pH ranges are about 6.5. The phosphorus losses, soil chemical fixation. The soil chemistry will lock it up, like I was talking about the aluminum and the iron and calcium. And then soil erosion, it's tightly bound to the soil. It doesn't move that far. So when we're losing soil, we are probably losing phosphorus. Phosphorus for soybeans, again, it starts on the lower leaves and moves upward. We have stunting, shorter internodes. So the plant might have as many internodes, but they'll be closer together, stunted. Not really purple, but we can see a lighter color, pale green leaves. They're a little bit more upright than a sufficient plant, and then it can delay maturity. What causes it? Again, not applying enough phosphorus, poor environmental conditions, too wet, too dry, limited root system. I didn't say too cold here because a lot of our soybeans are not planted at that time that we're being stressed by the weather. But limited root systems, low soil pH, high soil pH, same chemistries going on, whether it's corn or wheat or soybeans. It can be bound with aluminum, iron, and calcium. Our losses again, soil chemical fixation and soil erosion. Moving on to wheat. It's same thing, stunted growth. We'll see reduced tillering. It's not producing as many tillers, delayed maturing, and it's more prone to winter kill. We can see this is severely stunted compared to this wheat with sufficient phosphorus available. Again, when will we see this? What causes it? Insufficient phosphorus being applied. Too wet, too dry, too cold. Again, this is a winter crop, and it starts to somewhere late February, early March, it will start to break dormancy. And we also have slow mineralization of organic phosphorus, so that cold not only can reduce the amount of movement that the phosphorus will do, reduce the amount of root growth, but also reduces mineralization that's reducing it from organic matter. We can see it here, the purple leaves like corn compared to a good leaf. The loss mechanisms, again, soil chemical fixation and soil erosion. Moving on to potassium. Potassium is needed in large amounts, probably almost as much as nitrogen for most crops. It's mobile in the plants and sparingly mobile in the soil. It will move more than phosphorus, but not as much as nitrogen. So again, we will see that at the lower leaves moving up. It also regulates osmotic pressure in plants. So that's kind of one of the controls that influence nutrient uptake. And then it's involved with nutrient transportation in the plant. What are the deficiency symptoms for corn? Well, again, it's a mobile nutrient. It starts on the lower leaves and moves upwards. Mild stunting followed by yellowing to browning. It will start at the leaf tip or the margins and then progress back to the stalk, working towards the leaf midrib. This can have weakened stalk strength in corn and lower the disease resistance. We can see here it started on the tip of this corn leaf and it's starting to work backwards and in. What causes it? Again, not an adequate amount in the soil or not an adequate amount applied. The poor environmental conditions, too wet, too dry, too cold. However, the type of clay present, certain types of clay will fix potassium. So it's similar to the phosphorus, but a little different mechanism. Bottom line is, if you put it down, it can be fixed or taken out of the available pool by the clay. We have the soil chemical fixation, and it can be influenced by the type of clay, soil erosion, and then another issue that we will see with potassium more so than phosphorus or nitrogen is soil compaction or sidewall compaction. So we can see it here, overall picture, it's on these older leaves. It's starting at the tip, working towards the midrib and then back towards the plant. For soybeans, again, it's a mobile nutrient. It starts on the lower leaves and moves upward. So here's some stunted K deficient plants compared to some adequately fertilized soybean. It starts with mild stunning, then yellowing, and then as those leaves, the severity of the deficiency increases to browning and then leaf drop. Starts at the midrib at leaf tip and at the leaf tip and progresses towards the midrib and the petiole. So it's working back towards the stalk of the plant. Weak stalk strength and potassium deficient plants are more prone to lodging. It also lowers the disease resistance and can result in a smaller seed size. Causes, again, insufficient K applied or insufficient K available from the soil. We have the same typical poor environmental conditions, either too wet or too dry, the type of clay present, and then soybean cyst nematodes. They can damage the roots and influence the effectiveness of the roots actually taking up the potassium, more so probably than the other nutrients. The K losses, soil fixation, depending on the type of clay, and then soil erosion, and then soil compaction, sidewall compaction. Potassium deficiency in wheat, it again starts on the lower leaves and moves upward, mild stunning to yellowing to browning. So even though these are three different crops, the symptoms actually express themselves in a very similar way. So if you learn how these nutrient deficiencies express themselves, it's going to typically follow the same pattern regardless of the crop. So we'll have the mild stunning to yellowing to browning. It starts at the leaf tip, just like corn and the soybean, and then progresses towards the midrib and the main stem. It's going to work back to the stem. Weak stalk strength, more common to lodge than sufficient K being in the plant, and then lower disease resistance, smaller seed size. What causes it? Just not enough K present in the soil or being applied as the fertilizer. These same poor environmental conditions, too wet, too dry, too cold. Um, Clay can influence it, the type of clay, or losses again, soil fixation, soil erosion, and then sidewall compaction or soil compaction can lead to um, potassium deficiency in wheat. Okay, now we talked about we pretty much sounded like a broken record. We don't have enough. It's too cold, too wet, or something. But there's some other issues that we need to look at. If you were to look at this just real quick, the first thing that would come to mind is, oh, that's phosphorus deficiency, purple leaves starting on the older ones and working up. Well, actually, this is cold temperature. The cold temperature, we have several things working against it. Nutrient uptake is reduced by the plant. nutrient movement in the soil is reduced. Typically, the colder the soil, the less diffusion, the less movement you will have of the nutrients in the soil. The plants, if they can take them up, they might not be able to metabolize those nutrients. But most of the time, you see something like this, cold temperature, cold injury, the plant should grow out of it when it warms up. Every year I get a few calls. Hey, my corn's purple. I thought I had enough phosphorus down. What's going on? Don't look at it for a week. After get some warm weather, come back and see what you think. Most of the time, it looks a lot better. Saturated soils. Um, when the soil is saturated, there's no oxygen, nutrient uptake stops, the plant roots are deprived of oxygen. It can actually reduce nutrient availability of some nutrients, and then you also have deposition of sediment and residue that can also kind of influence your availability of oxygen is more or less what it comes down to. Anytime you can scout your wheat field in a canoe, you're probably going to have some issues. So this might show nitrogen deficiency, potash deficiency, phosphorus deficiency. Well, actually, it's oxygen deficiency, and the plant's just not able to take up the nutrients. So that's something to consider. Soil compaction. You can see the layers here. This is a highly compacted soil. It limits root exploration, root penetration. The nutrient or the roots just can't get to the bulk soil as well to find the nutrients or to acquire the nutrients that are there. Um, Compaction reduces the nutrient movement. It also reduces water infiltration, so it kind of compounds that factor. Plants are not able to, you know, take it up. They don't have as much water to help them grow. It's just kind of a snowball effect. It increases the chances for water to pool and then reduces overall plant available water. So you can have, nitrogen, potassium, phosphorus deficiency showing, but it might not be due to nutrient low nutrient availability or low nutrients present. It might just be a physical issue going on. Here's a few more pictures of compaction. This one here we can see is almost like they were growing on a concrete floor. They didn't make any downward penetration. You can see here that's flat root system versus a good root system that's growing downward. Here's sidewall compaction in these two pictures. The plant, these were planted just a little bit too wet. The furrow did not get closed back. However, it slicked or sealed the sidewall, so the roots are not able to penetrate outside of this furrow, and it greatly reduced the amount of soil that it could explore for nutrient uptake. Soil pH. I'm a soil fertility guy. The soil pH, a good liming program is the root. That's the key to a good soil fertility program is having a good liming pH management program. So if your nutrient or if your pH is too low or too high, it limits nutrient uptake. Especially for phosphorus and then a lot of your micronutrients. This lower high soil pH can also reduce root growth and it impairs the root functions. They don't make as many small, fine hairs, the ones that do the heavy lifting for nutrient uptake. And then it can also influence herbicide activity. If you have a lot of weeds present, you're probably going to show some nutrient deficiencies because they're going to be more effective at getting that water and those nutrients than that primary cash crop that you're growing. So we typically say somewhere in the area of 6.5 is ideal. These bars, the fatter the bars are, the more available those nutrients are. So you can go down here and find, for the most part, we're hitting the fat part of these bars. They're fat enough. If we get too low, manganese availability tremendously increases. Manganese is an essential nutrient. However, if you have too much of it, it can actually cause issues in the plant. So pH management is the key to a good soil fertility program. Few tools to diagnose whether you have a nutrient deficiency or something else include a soil probe right here. You can determine a whole lot with a soil probe. Not only is it good for taking a soil sample, but you can feel a lot. If you can't get your probe in the ground more than 2 inches because you hit a limiting layer, chances are you might be dealing with compaction. Tissue sampling, pulling tissues, the proper tissue at the proper time, that can tell you a whole lot. A penetrometer, a sharp, I guess a probe that you can push in the soil, and it actually measures how much force it takes to push in the soil. A shovel, you can learn a lot with a shovel, dig up some plant roots. So what I would like to do when I get called to help diagnose a problem, I will look at good areas and bad areas in the field and then use some or all of these tools to help decide, is it truly a nutrient deficiency or is there some other stress doing that? And then site history, just knowing what's been going on for that site can help out a tremendous amount. So we're getting close. We want to look at some similar but different deficiencies. And this is something I like to say. Sometimes you can use patterns, what's that pattern showing me? Maybe I had a poor spreader pattern. Sometimes you can use the field history. Well, I know that we used to have dairy cattle here, so this part of the field is really good, whereas the other isn't. Well, environmental conditions. Again, if you can scout your wheat with a kayak, probably there's some sort of environmental condition that's leading to this. And then sometimes you can use tools, but it doesn't matter what you use, you need to always use good reasoning skills. Just because it's potassium deficiency doesn't mean it's because I don't have enough potassium in the soil or I didn't apply enough. Need to use reasoning skills along with the tools to determine what's going on. So if you look at these real quick, well, we have browning, we have yellowing, and we have it, kind of looks similar, but these are two different deficiencies. This is nitrogen starting at the midrib working out, coming back to the plant, and then this is potassium deficiency starting at the leaf edge, the leaf margin, working in towards the midrib and then back to the plant. Again, this is the potassium deficiency over here on the right slide. Well, this is kind of yellowing. Well, this is sulfur deficiency. Um, it's not on the older leaves, it's on the newer leaves. Sulfur is relatively immobile in the soil, or in the plant. So the plant is not taking it from the older leaves, it's just not able to produce enough sulfur to have that dark green color in the older leaves. We have purple corn and we have purple corn. Quick glance, if you just walked into this field, oh, that's phosphorus deficiency. This is phosphorus deficiency. Well, this had more than adequate phosphorus in the soil. We confirmed that with a soil test. However, we were just coming out of a cold snap, so this was cold injury. So that's all I have. I want to leave you with this picture of wheat. We have adequately green and growing wheat here in the background, and then some deficient wheat up here. And it's a nutrient deficiency. However, it was probably brought on by ground disturbance. It was, something that, yes, there's not enough of that nutrient. And this is actually sulfur deficiency in the soil, but it was because they burned a bunch of brush piles, they buried it, they disturbed the soil. So there's just a little small area here and there in this larger field. So remember, use common sense, use your patterns, use your tools. That's all I have. If you have any questions, feel free to reach out at me. Reach out to me. My email address is edwin.ritchie@uky.edu. Thank you.